If min-max and maximum value is not equal, then the saddle point is not equal. If the saddle point does not exist, then that strategy is called as mixed strategy. The concept of this dominance theory is especially useful for evaluation of two-person zero game where a saddle point does not exist. Overall outcome for all the players in the game would be zero at the end of the game. Hello dear students, welcome to this session of our Operation Research class. I am Mr. Niranjan, Faculty, Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence. Today in this session, I am going to discuss regarding very important and very easiest unit, the topic game theory. So it's very simple concept you are going to study and very easy. In this session, I am going to teach the definitions and the problems. In total, the game theory will carries one full question, one 7-mark and one 8-mark question, that is 15 marks, and one or two definitions for 2 markers. So around 20 marks you will get from this game theory. Now, let me discuss what is meant by a game theory and what are the different methods which we are going to study in this game theory. Now, let us come to the concept. What is meant by a game theory? So, this is nothing but the mathematical study of a model of strategic interaction. So, game theory is the study of mathematical models. It is a study of mathematical models of strategic interaction among the rational decision makers. Right. It has application in almost all fields of social science as well as in logic, and this is also very applicable in the system science and computer science. Originally, it is addressed zero-sum games. Originally, the game theory addressed as the zero game, in which each participant gains or loses are exactly balanced by those of the other participant. That is why this is called a zero game. Here, the participants gain or loss are exactly balanced by those other participants. So that is why we are referred this as zero games. Now, today this game theory applies to a wide range behavioral relations and is now an umbrella term for the science of logical decision making in human, animals and also in computers. So now let us know regarding assumptions of game theory. There are few assumptions. What are the assumptions of game theory? There are few assumptions. Based on these assumptions, we are performing the output. We are going to solve the problems for a game. Now, the game theory provides an appropriate solution of a problem if its conditions are properly satisfied. So, if the conditions are properly satisfied, then the game theory will provide appropriate solution of a given problem. To get an appropriate, the perfect solution for a given problem, we have to follow certain conditions. These conditions are often termed as the assumptions of the game theory. These are also called as the assumption. So there are few assumptions or conditions. So to get the appropriate solutions of a game, we are going to use some assumptions. We are going to apply some conditions. So what are these conditions? Some of these assumptions or conditions are as follows. First, assume that a player can adopt multiple strategies for solving a problem. Suppose if a player applies more than one strategy, if he applies multiple strategies for solving a problem, then assume that there is an availability of outcome. Now, assume that the overall outcome for all the players would be zero at the end of the game. Assume that the overall outcome for all the players in the game would be zero at the end of the game. The overall outcome is zero for all the players at the end of the game. Now, assume that all the players in the game are aware of game rules as well as outcomes of the other players. So, assume that all the players in the game are aware of all the rules of the game. So if they are familiar with all the rules of the game as well as all the outcomes of the other players, they are also familiar with the outcomes of the other players. Now, finally, assume that the player takes a rational decision to increase their profit. Assume, suppose if any player takes a rational decision to increase their profit. So these are few assumptions of a game theory. So in the examination 5 marks they may ask a question, what are the assumptions of game theory? So there are 5 assumptions, you have to write all these 5 assumptions. That is, some of the assumptions, or this is also called as the conditions of the game theory. Assume that a player can adopt multiple strategies for solving the problem. And the second one is, assume that there is an availability of predetermined outcome. If there is an availability of predetermined outcome, and also assume that overall outcome for the player would be 0 at the end of the game. Assume that all the players in the game are aware of the game rules as well as the outcome of the other players. And finally, assume that the players take a rational decision to increase their profit. So these are the few assumptions of a game theory. Now let us come to the next concept, is minimax and maximin. So you may expect a question for 2 marks like define minimax and maximin. So this is important 2 mark question. Now minimax, as the name suggests, it is a method in decision theory for minimizing the maximum loss. So minimax, the name itself indicates this is the method in decision theory for minimizing the maximum loss. That is called min-max. Minimizing the maximum loss. Alternative, it can also be thought of maximizing the minimum gain, which is also known as maximin. Maximizing the minimum gain, that is called as a maximin. Okay, so here minimax is nothing but it is a method in decision theory for minimizing the maximum loss. To minimize the maximum loss, alternatively, it can also be thought of maximizing the minimum gain, which is also known as maximin. Now, it also started from 2-player and zero-sum game theory, covering both the cases where the players take alternative moves and those where they have made simultaneous moves. So alternative moves as well as the simultaneous moves. And this game theory is also extended to more complex games and to general decision. So this is extended to the more complex games as well as general decision in making in the presence of uncertainty. So now let us come to the next concept, zero sum. So here the important concept is zero sum. Zero sum game is a special case of constant sum of games. So this is the special case of constant sum of a game in which the choice by players can neither be increase nor decrease the available resources. Zero sum means here the choice of a player, the choices of a player can never increase or decrease the available resources. That is why this is called a zero sum game. So that is, the choice of a player can neither be increase nor decrease the available resources. In zero sum game, the total benefit to all players in the game for every combination of strategies always adds to 0. So in this zero sum game theory, for all the players, the benefits for every combination of strategies always adds to 0. So that means, more informally, a player benefits only at expense of the other. That is called a zero sum. Now, let us know what is meant by non-zero sum. So in non-zero sum, many games studied by game theorists consist of non-zero sum games because of some outcomes have net result greater than or less than 0. Non-zero games have been studied because of the outcomes results greater or lesser than 0. Informally, in non-zero sum games, a gain by one player does not necessarily correspond with a loss by the another. So, informally, suppose if there is a gain for one player, it does not necessarily corresponds with the loss by the another player. Now let us come to the next concept, Maximin theory. What is Maximin? Maximin, that is maximum in minimum. So this is a term commonly used for non-zero sum games. Maximin is a common term which we are going to use for non-zero games. So to describe the strategies which maximizes one's own minimum payoff. So here this is a term commonly used for non-zero sum games to decide the strategies which maximizes one's own minimum payoff. Now getting back to the Minimax algorithm, the Minimax algorithm is a rescue algorithm for choosing the next move in an n player game, usually a 2-player game. Okay, now let us come to the next concept, saddle point. Saddle point in the game theory refers to the available of a function of 2 players which is a maximum with respect to one and minimum with respect to the another. So saddle point is nothing but the saddle point in the game theory refers to the value of a function. It refers to a value of a function of 2 players which is maximum with respect to one and minimum with respect to the another. So if it is maximum with respect to A and minimum with respect to the B. So the point of intersection between maximum and minimum of A and B is called the saddle point. So saddle point in the game theory refers to a value of a function of 2 players which is maximum with respect to one and minimum with respect to another player. Now let us come to the dominance theory, dominance game theory. What is the principle of dominance of game theory? Principle of dominance in game theory, also known as dominance strategy or dominance method. The principle of dominance in game theory is also known as dominance strategies, or it is also called as dominance method. Now, this states that one strategy of a player dominates over the other strategy in all conditions. The strategy of one player will dominate the strategy of other players in all the conditions, then the later strategies can be ignored. So here in dominance of one over the other. So that means in dominance theory, this states that if one strategy of a player dominates over other strategies in all the conditions, the later strategy can be ignored. The concept of this dominance theory is especially useful for evaluation of 2-person zero game where a saddle point does not exist. If a saddle point does not exist, then this type of dominance theory can be used. That is, this dominance theory, the concept of dominance theory is useful, is especially used for evaluation of 2-person game, 2-person zero-sum games where a saddle point does not exist. If a saddle point does not exist, we are going to use this dominance theory to evaluate the game. Now, let us come to the dominance strategies rules or dominance principle. What is meant by the dominance principle? So, this is very important concept. If all the elements of a column, this is a column, say ith column are greater than or equal to the corresponding element of any other column, say jth. If all the elements of ith column is greater than or equal to jth column, then ith column is dominated by jth column. So if it is greater, ith element, the elements of ith column is dominated by the elements of jth column. So if all the elements of a column, say column number I, first ith column is greater than or equal to the corresponding elements of any other column, say jth column, then ith column is dominated by jth column and can be deleted from the matrix, and that can be deleted from that matrix. Similarly, if all the elements of a row, this is corresponds to a column. Now suppose if all the elements in a row, R1 and R2 are the rows. If all the elements of a row, say ith row, are less than or equal to, the first condition is greater, here less than or equal to, is less than or equal to the corresponding elements of the other row, say jth row, then ith row is dominated by the jth row, can be deleted from the matrix. So that is called the dominance strategy. This is dominance principle, or the dominance strategy rule states that if all the elements of a column are greater than or equal to the corresponding elements of other column, then ith column, that particular column is dominated by the jth column and it can be deleted from the matrix if it is greater than or equal to. Suppose if it is less than or equal to, if all the elements of a row are less than or equal to the corresponding elements of that other row, say I and jth row, then ith row is dominated by jth row and it can be deleted from the matrix. The first condition is greater than or equal to and the second condition is less than or equal to. This is what is called as the dominance principle. Okay, very important concept. Now let us discuss regarding pure strategies and mixed strategies. What is this pure strategy? Pure strategy is nothing but the simplest type of a game is one where the best strategies for both the players are pure strategies. That is, this is one of the best strategy for both the player A and player B are the pure strategies. This is the case if and only if the payoff matrix contains a saddle point. If a saddle point exists, then only we are going to call it as the simplest type of game, that is called the pure strategies. So listen to me here. The simplest type of a game is one where the best strategies for both the players, the player A and player B, are pure strategies. That means this is the case if and only if a saddle point exists. A saddle point exists, that is if and only if the payoff matrix contains a saddle point. Now, in a pure strategy, player adds a strategy that provides the best payoff. In other words, a pure strategy is the one that provides maximum profit. So, a pure strategy is one which will provide the maximum profit or the best outcome to the player. So, it will provide the maximum profit or the best outcome. We are going to get a maximum profit or the best outcome for the players. So therefore, it is regarded as the best strategy for every player of the game. That is pure strategy game. So this will give the maximum benefit, maximum output, maximum profit or the best outcome for the player. So therefore, this is regarded as the best strategy for the players of the game. So that is regarding pure. Now, mixed strategies. What is meant by mixed strategies? In mixed strategies, a situation where a saddle point does not exist. If min-max and maximum value is not equal, then the saddle point is not equal. If the saddle point does not exist, then that strategy is called as mixed strategy. A mixed strategy where means a situation where a saddle point does not exist. So that is max-min is not equal to min-max value, then the strategy is called a mixed strategy. So these are the few concepts regarding this game theory. Now let us take one simple problem. Let me take a problem. Now the problems, usually they will ask the problems like this. So you may get one definite question from this type of problem. Find the saddle point and the value of the game. So this is 3 rows, 3 column. What are the players given? Players A1, A2, A3, B1, B2, B3. The saddle point of the game. So we have to find the saddle point and the value of the game. Okay, let us take this problem. I'll take the solution here. Solution. What is given? So the matrix here A1, A2, A3, B1, B2 and B3. Okay. Now, what is here given? So to find, what is to find? The saddle point and the value of the game. So saddle point, find maximin and minimax values. So just find out maximin and minimax value. First find out maximin and minimax value, then see whether they are equal or not. If they are equal, that itself is called the saddle point. Now let us write the problem here. So in A1, first row 15, 2 and 3, 15, 2 and 3, second 6, 5, 7, 6, 5 and 7, minus 7, 4 and 0. So this is the given problem. First find out row minimum. Let me write row minimum. Row minimum. So row minimum means the minimum value in that particular row. What is the minimum value here? The minimum value is 2. And what is the minimum value? 5. The row minimum value is minus 7. First row. In first row, the minimum value is 2. Minimum value is 5. Minimum value is minus 7. Okay. In this minimum value, find out the maximum value. That is called maximin. Maximin. That means maximum in this minimum. What is the maximum in this minimum? 5. 5 is the maximum in this minimum. Okay. Now let us come to column maximum. Column maximum. What is the maximum in first column? In first column, the maximum value is 15. In the second column, the maximum value is 5. And in the third column, the maximum value is 7. So 15, 5 and 7 are the maximum values in that particular first column, second column and third column. Right. Now find out the minimum value in this maximum. So minimum value, minimax, that is called minimax. Minimum value in this maximum is 5. So 5. See, the minimax value is 5, maximin value is equal to 5. So here maximin value is 5. Then minimax value is also equal to 5. So therefore, this is called the saddle point. Therefore, the saddle point is, this is the saddle point. So the saddle point is equal to 5. The saddle point is 5. So minimax value is 5 and maximin value is also 5. Therefore, 5 is the saddle point for this game. So therefore, the optimal strategy for the game A, optimal strategy for A is A2, and similarly the optimal strategy for B is B2. These are the optimal strategy. The optimal strategy for the player A, is A2 and for the player B is B2, and the value of the game is equal to 5. That's it. So this is how we are going to solve. Very simple problem. Let me see here. I will explain once again. So this is the problem given. First find out row minimum. So in first row the minimum value is 2. In second row the minimum value is 5. And in third row the minimum value is minus 7. Find out the maximum value in this minimum. The maximum value in this minimum is 5. So therefore that is called maximin. Maximin is 5. And similarly find out the column maximum. Maximum in first column is 15. Maximum in second column is 5. And the maximum in third column is 7. And find out the minimum in this maximum value. Minimum value in this maximum value is 5. 5 is the minimum. That is called minimax. So maximin is 5, minimax is equal to 5. Therefore, the saddle point is equal to 5. That means the value of game is 5 here. And therefore, A2 is the optimal strategy for A. And for optimal strategy for the player B is B2. This is how we are going to solve. This is the method to solve the given problem. Very simple method. Now, Let us take one more problem. Now, find the optimal strategy of the players in the following game. Now, we have to find the optimal strategy for the player A and player B. Now, let us find out the saddle point for this. Find out the min-max value and max-min value and the saddle point, and then we can judge the optimal strategy for the player A and player B. Now, let us write down what is given here. Now, just what is to find? Just find the optimal strategy. So, before that, find out the saddle point. If maximum value, that is min-max value and max-min values are equal, then that is called the saddle point. First, find out min-max and max-min value, then we will find the optimal strategy for the given problem. Now, what is the problem given here? It is, so this is 25, 20, 35, then 50, 45, 50, 45, 55, then 58, 40, 58, 40, 58, 40, 42. So, this is 1, 2 and 3 for player B. This is 1, 2 and 3 for player A. Now, just find out max min and min max values first. Let me find row minimum. First row minimum. So, what is the minimum value in first row? This is 20. The minimum value in the second row is 45. What is the minimum value in the third row? It is 40. So, the first row minimum value is 20. In the second row the minimum value is 45, and in the third row the minimum value is 40. Okay. Now, find out the maximum in this row. Max min, that is called max min. Maxi min. That means maximum in this row. The maximum in this row is 45. 45 is the maximum value in this row. Okay. So, first find out row minimum. After getting row minimum, find out the maximum in this row minimum. It is 45. Now, let us come to the column maximum. Similarly, find out the column maximum. Maximum value in first column. In first column, the maximum value is 58. In the second column, the maximum value is 45. In the third column, the maximum value is 55. So, here just find out minimum value, here the maximum value. The maximum values are 58 for the first column, 45 for the second column and 55 for the third column. So, after finding the maximum value, find out the minimum value in this maximum. That is, minimum in this maximum is called minimax. So, this is the minimum value in maximum, that is 45. See here the difference. What is the maximin and minimum value? Minimax. So, maximin is equal to minimax is equal to 45. So, maximin is equal to 45, minimax also equal to 45. Therefore, this is called the saddle point. Saddle point is equal to 45. The saddle point is equal to 45. This is the value of the game. Now, find out the optimal strategy for the player. So, the optimal strategy for the player A in player B. Just find out the optimal strategy for the player A and player B. So, therefore, the player A is called the maximin player. Player A is called maximin player. So, here the player A is called maximin player. Similarly, the player B is called min-max player. That's it. So, here the player A is called max-min player and player B is called the min-max player. This means the player A is maximizing its minimum value and the player B is minimizing its maximum value. So, this is how we are going to solve a problem finding the saddle point, right? So, that's all regarding today's session. Let us meet with the different concept in the next session. Thank you very much.